Hi all, I'm going to go through on two examples on applications of right angle triangles today. Let's read the first one. So our learning intention is applying our trigonometric ratios in problem solving. So let's read this. The log is 3 meters long and it is resting on the top of a post, and the base lengths are 2.8 meters apart. I'm going to look at the angle the log makes with the ground. So where is that? So that's right in here. That is the angle from the horizontal plane. Now that's my reference angle which has to be found. I'm looking at all the data given here. Of course, this is a right angle triangle. Therefore, I could say this is not ABC. Let's say PQR. It's just because I'm going to use the letter A again. Relative to the reference angle here, the diagonal, of course, here is hypotenuse. And what is this 2.8? What is given? Is it adjacent or opposite? So you can see it's next to the angle, so it's adjacent. Now I have adjacent and the hypotenuse and the reference angle to be found. So what type of a ratio are we going to use? Either sine, cosine, or tan. Which one is that? Thinking? So that's cos. So cos theta, let me do that in a different color. Cos theta is equal to adjacent over hypotenuse. Well, adjacent is 2.8, hypotenuse is 3. You can simply work this one using the CAS calculator. Solve for theta. So let's see how we do that. Okay, let's get the keyboard up. So we type solve, go to the trig, and then you type cos. Now in this case theta, I would rather type x and then solve for x, and assuming my x in this calculator is in fact the theta that I need to find. Close the bracket. So I need to close the bracket, and then I say equal, and then simply type as it is. I would normally use this fraction because that's pretty clear when you type in. So let me pull this up again a bit. 2.8 on 3. Now you solve for x. Let's see what happens when I enter. Yeah, well, look, that's a bit weird. What's causing this problem? Well, just before we look at that one, let's go back to our notes and see whether we can simply write this one in a different way. So if cos theta equals 2.8 on 3, we know from finding angles that formula where we can write down theta is in fact now cos inverse 2.8 on 3. Now let's go back to our calculator and type this in and see what comes up. So my settings are decimal and degrees. Cos inverse, I type the fraction there, 2.8 divided by 3, and then I press enter. I do get an angle 21.04 degrees. So 21.04. Let's write that here first. That's our answer. So what I would encourage you to do is do this one, or this is actually correct to one decimal place. Therefore, just 21.0. That's it. That's my answer. Just carefully read this, please. And if I were to solve as I just type solve, I get a sort of like a nasty answer. Let's see whether I can actually get this value of that long expression. If you compare these two, here it is, that value. So of course, if you go a bit further, you will have that as either plus or minus, somehow with either 360 and another constant term. So what your focus should be just that value. So simply you can pick that value as the answer. That is your answer in fact. and this comes as a repetition just because of this circular function cos theta, or even it's same for this tan and the sine as well. Now just remember, either you type inverse straight away, or if you typed solve based on your first equation, you got to pick up that value, not anything else here. So just positive figure of that value will do. Okay, let's go to the next one. Right, here we have a mountain. Now the distance measured up the sloping face is 3.8. So that's 3.8. That's kilometers. And sloping face was at an angle of 52. That's my reference angle. Just write in here, it's 52 degrees. Now what is being asked? Make a copy. Yeah, of course we done that now. Show the height of the mountain as x. So that's x. I need to find x using these information. So what do we use? Do we use sine, cosine, or tan? Well, this is my reference angle 52. So when it is 52, I have been asked to find the opposite given the hypotenuse. So the opposite here, hypotenuse there. So what goes with opposite and hypotenuse? The sine. So you write down sine, in this case 52, is equal to opposite over hypotenuse, in this case 3.8. Now you can solve x for this one straight away using the solve. So let's do that. Or you can multiply 3.8 to the left hand side, and still you need to punch into the calculator. So let's do with the cas. I'm going to type solve, trig sine, type 52, and I know this is in degrees. I don't need to put the degree sign, otherwise I have to, equals, then I write down the fraction as it is, x on 3.8. Yeah, I'm typing that correctly, and then I'm going to execute here. That gives me 2.99. Now it's asking correct to 1 decimal place. So if it is correct to 1 decimal place, let's round off. X is approximately 2.99 and so on and so forth, blah blah blah. Now rounding off to the 1 decimal place, well, you got to round this one up. That means I would get this one is 0 rounded up here as a 3.0 kilometers. So that's my answer. Righty, hope that's clear. Good luck with your work, and I'll catch you again in our next video lesson. Bye for now.